Hi, I'm Sean Gannon, and this is Minute Math. And we got a math problem here. We want to calculate the area of the inner triangle that is inside of a square. And they give us some information about this figure. We have square A, B, C, D, all right, has all the properties of squares. We have some areas that are given from the triangles inside of them. CDF has an area of 3. AEF has an area of 5, and BCE has an area of 4. Can you find the area of our inner triangle? I want you to take a moment, pause this video, see if you can figure it out, and once you've completed that, just follow along and we'll go solve this problem. Alright, since we know that A, B, C, and D is a square, has all the properties of squares, meaning, well, all the corners are right angles. Most importantly here for our problem here, well, toss that little in there for some of them. I'll avoid that one. The side lengths are all congruent. And so if that's the case, let's go label the side length. Let's give it a variable. Let's call it x, everyone's favorite variable here. So x is going to represent here the length of each side length of the square. All right. Now, we want to find the area of the inner triangle. And to do that, I'm actually going to try to take some knowledge of areas of triangles in general and apply that to our other triangles to try to find some, well, missing values, write things in context here, okay? So let's go look at our triangle BCE, triangle BCE here first. So we have triangle BCE I'm gonna work with first here, and we know that the area of a triangle is equal to 1/2 base times height. So that triangle's area is equal to 1/2. The base, we don't know yet, let's call it B, but our height, B to C, is x. And it's equal to the area of, well, 4. So to simplify this, we multiply 2 to both sides, and we have Bx is equal to 8, getting some clarity here. And I want to get B by itself, so I'm going to divide both sides by x, and I have B, that length here, right, this B right there, is equal to 8 over an x. So instead of B, I'll write, well, 8 over an x there for that length from E to B. Let's go, length EB. And we can do this actually again with our upper triangle right here. Let's do with that one here. Triangle CDF, same idea, CDF here. That has an area of 1/2. Our base, let's call that x, right? Let's call that x right here, times our height, what do I want to call that? Height here, let's call it h, okay? Oh wait, no, yeah, I call it h. I did call it h, you're right. So I call it h here, and we know it's equal to a 3. From there, I'm gonna see if I can rearrange this bad boy here, and I wanna get h by itself. Multiply both sides by 2, 3 times 2 is a 6, divided by, well, x, and I have h is equal to 6 over x. So instead of that h, I'll put h on the inside here, I have a 6 over an x, that length, which is the length of FD. Now what about the length here of AE and AF? Can I find those? Well, if I know the overall length of AB is x and EB is 8x, AE would be x minus an 8x. And similarly, DA we know has a length of x, and DF has a length of 6 over x. FA will be an x minus a 6 over an x. So triangle AEF, its area is going to be equal to 1/2 our base, x minus 8 over x, times our height, x minus 6 over x, right there, and we know that's equal to 5. Okay, actually, I'm going to rewrite that over here. So multiplying out, I'm going to multiply 1/2 here to both sides to get equal to 10. So 1 times by 2, 5 times 2 is a 10. I'm going to put it on this side so I have a little more space. And 10 is equal to x minus 8 over x times an x minus 6 over an x. All right, to simplify this, let's go get some like terms here in the denominator. Let's combine these fractions. So keep the 10 out here. And x is really can be x squared over x, has the same denominator, so we have an x squared minus 8 over an x here. Same idea here, x squared minus a 6 over an x. And so we can multiply this out, 10 equals x squared times x squared, x to the 4th, minus x squared times negative 6 x squared, plus a negative 8 times x squared, as a negative 8x squared, add them together, and we get a 14x squared, and then negative 8 times negative 6 comes out to be a positive 48, all over x times x, which is an x squared. Multiply x squared to both sides, we're gonna kind of simplify, try to get everything equal to 0. Doing that, we have 10x squared equals x to the 4th minus 14x squared plus a 48. Bring the 10x squared over to the right hand side, let's get it equal to 0 here. So 0 is equal to a good old x to the 4th minus 24x squared plus a 48. And here, I'm gonna try to solve for x. A technique you can do is like a u substitution here. And so what I'm gonna do is say, hey, x squared is equal to a u in a way. So this problem becomes here, and we'll bring it back later, u squared minus a 24u plus 48. All right, so I actually solved this using the quadratic formula. And if I remember to put it in there on the card, I'll show a little, beep, that says, hey, we have a cool song video about the quadratic formula from way back when, like 10 years ago. I'll just put a link in the description there. So hopefully you like that little quadratic formula song. But either way, going on through here, and what I want to do is, quadratic formula gave me two values, and I have u is equal to a 12 is plus or minus, so we'll do the first one plus 4 square root of 6 was one of the solutions, and u could equal a 12 minus a 4 square root of 6 here. Now, the second solution, that comes out to be approximately a 2.2, right? And a u value of a 2.2, and remember we're squaring that to get the value of x, doesn't really make sense. So why does 2.2 not make sense for u? Well, 2.2, u being 2.2, would mean x squared is equal to 2.2. X squared kind of gives me the area of the whole square here, and there's no way the whole area of the square is 2.2. We have areas of 4, 5, and 3. So we can reject that, and we have to deal with a 12 plus 4 square root of 6. So like I said, that's going to be equal to our x squared. So x squared is equal to 12 plus a 4 square root of 6. All right, I'm going to go erase some work here so we have some more space, but we're almost done. Bear with me. All right, so we want to find the area of ECF. So triangle ECF is equal to the area of our square minus all these other parts, the triangles, right? Each little triangle, which is 3 plus 4 plus a 5. So keep on going. Our triangle of ECF is equal to our square, again, minus 3 plus 4 plus 5. And so our square has an area of x squared, or a 12 plus 4 square root of 6. And we want to subtract 3 plus 4 plus 5, which is a 12. And isn't this lovely here? 12s cancel out. And we have 4 square root of 6. And that's the area of triangle ECF as 4 square root of 6, or approximately a 9.79796 units squared, right there. But either way, we got our answer. About 4 square, or exactly 4 square root of 6 is the area of that inner triangle region. Did you get that value? If you did, way to go. I approve. If you didn't, well, I hope you learned something here on how to solve this type of problem. Don't forget to like this video and subscribe to our YouTube channel. This helps us make more of these fun math videos for you and for everyone else. So as always here, thanks for watching.